When you hear the term SCADA, what comes to mind? Maybe control rooms with screens full of data, alarms flashing, or operators keeping an eye on every process in a facility. But SCADA, or Supervisory Control and Data Acquisition, is way more than just fancy software or sensors. It's really the backbone of automation, the system that keeps everything running smoothly, efficiently, and safely, whether you're talking about a manufacturing plant, a water treatment facility, or even a data center. And before we jump in, make sure to hit that like button and subscribe to the channel for more videos on automation, control systems, and industrial monitoring. Alright, so let's start with the basics. SCADA stands for Supervisory Control and Data Acquisition. That's a long phrase, but what it really means is this. SCADA is a combination of hardware and software that lets you monitor and control equipment both locally and remotely in real time. Here's what that looks like in action. You've got sensors and field devices out in your facility, measuring things like temperature, pressure, flow, or voltage. Those devices then send their data to controllers like PLCs or RTUs. Then your SCADA software takes all of that information and displays it on an HMI, a human-machine interface, so you can actually see what's going on and make decisions when needed. Basically, SCADA takes all the moving parts in your operation and turns them into a live, visual system you can understand and control from one central place. Now, this whole concept didn't just start overnight. Before SCADA existed, operators had to physically walk the plant floor to check gauges, flip switches, and write down readings. It worked, but as facilities grew larger and more remote, that approach became impossible to keep up with. The first step toward automation was using relays and timers. They were helpful, but the panels took up a ton of space. Troubleshooting was a pain, and every time you needed a change, you had to rewire everything. Then came the 1950s, when processors and programmable controllers changed everything. And by the 1960s, telemetry systems allowed data to be sent remotely, and that's really where SCADA began. The first SCADA systems in the 70s were massive mainframe-style setups, powerful but limited. They were proprietary, closed loops that couldn't talk to anything outside their own network. Then by the 1980s and 90s, things got a lot more flexible. With local area networks, or LAN, and early HMI software, you could finally connect multiple stations together. That's when distributed SCADA systems started showing up. Then, in the 2000s, open communication protocols like Modbus TCP, Ethernet/IP, and OPC changed the game completely. Now, different vendors could finally talk to each other. And today, SCADA has gone fully digital. Modern systems use SQL databases, web dashboards, and cloud access so you can check in on your panel or your data center from anywhere in the world. So how does modern SCADA actually work? Think of it as 4 main layers, all talking to each other. First, you've got your field devices, sensors, transmitters, and meters, basically anything collecting data. Next are your controllers, like PLCs or RTUs. This is where products like our M7000 series I/O modules come in. They act as the bridge between your sensors and your control system, collecting real-time data and passing it along reliably, even in noisy or industrial environments. Then you've got your communication layer, which is your network. It could be Ethernet, cellular, or even wireless depending on your setup. And if you're trying to connect older serial devices into a modern Ethernet-based system, you could use something like a TGW Modbus Gateway. That device basically acts as a translator between Modbus RTU and Modbus TCP, letting legacy equipment plug right into your SCADA network without any rewiring or code changes. Finally, you have your SCADA software, the visualization layer. That's where you can see live data, analyze trends, and trigger alarms or automated responses. It's what lets operators take all of that field information and make quick, data-driven decisions. SCADA has been around for decades, but it's more relevant now than ever. Modern SCADA systems don't just show data, they analyze it. They help engineers detect problems before they cause downtime, optimize energy use, and even predict maintenance before something breaks. It's all about efficiency, uptime, and control. For example, in a data center, SCADA can monitor everything from rack temperature to power load, helping operators react before a problem affects uptime. In a water treatment plant, it could control pumps and valves automatically. And in manufacturing, it gives managers complete visibility of every process from production lines to energy usage. Here at ICP DAS USA, we make the building blocks that help engineers and system integrators bring their SCADA systems to life. Our WISE controllers act as the brain of the system, collecting data, running logic, and sending commands based on real-time conditions. Combine that with an M7000 series I/O module or a TGW gateway, and you've got everything you need to connect sensors, log data, and control devices across an entire facility, no matter the brand or age of the hardware. Whether you're upgrading an older control network or building a new one from scratch, our products make it easier to connect, monitor, and automate with confidence. If you found this video helpful, give it a like and hit subscribe for more automation tutorials and industry explainers. And if you want to learn more about how ICP DAS USA can fit into your next SCADA project, you can visit icpdasusa.com or contact us directly at sales@icpdasusa.com. Thank you so much for watching this video, and we'll see you in the next one.